So hi guys, today we have question 2 from objective 1, chapter 15, wave motion and waves in a string. So the question reads as follows. A sine wave is traveling in a medium. A particular particle has zero displacement at a certain instant. The particle closest to it, having zero displacement, is at a distance. Now we're going to solve this question using two methods. Method 1 is using the general wave equation for a traveling sine wave. So we say that y is equal to a sine of omega t minus kx plus phi, where a is the amplitude of the wave, omega is the angular frequency, k is the wave number, phi is the phase angle, initial that is, t is time, and x is position. Now, zero displacement implies that y must be zero. And since the wave exists, a is not zero, which would imply that sine of omega t minus kx plus phi is equal to 0. Now the sine function attains a value of 0 at integral multiples of pi. Hence we'll say that omega t minus kx plus phi is equal to n pi, where n is an integer. And we'll call this equation 1. And say the instant is at t is equal to t1 and the position mentioned in the question is x is equal to x1, which would imply that omega t1 minus kx1 plus phi is equal to n pi. Now say y is equal to 0 at some other position x is equal to x2 as well. This would mean that omega t1 minus kx2 plus phi is equal to m pi, where m is again an integer by similar logic. And we'll call this equation 2. Hence subtracting equation 1 and 2, that is, we are operating 1 minus 2, we get k into x2 minus x1 is equal to n minus m into pi, where k is 2 pi by lambda and lambda is wavelength. So substituting it in the equation, we get 2 pi by lambda into x2 minus x1 is equal to n minus m into pi. This implies that x2 minus x1 is equal to lambda by 2 into n minus m. Now, for minimum, we'll set n minus m equal to 1. And hence, our answer will be equal to lambda by 2. And that will be option C. Now, method 2 is we take a snapshot at any general instant t is equal to t1. And as you can clearly see in the diagram below, 2 points or particles whose displacement along the y-axis is 0, that is y is equal to 0, are separated by a distance of lambda by 2, as the entire snapshot in the diagram below covers one complete wavelength or lambda, and hence the answer is lambda by 2.